Hey there, physics fans. What I have for you is an electricity question here. And this question is actually a little bit complex. It really makes us think. It requires that we understand differences between parallel and series circuits, and then it also really makes us think about where the current or the electricity is flowing. It's looking for the current, which is shown as I, in the 10 ohm resistor. So it's looking for the current here, okay? We're looking for I. Now, in order to find the I in a particular branch, we need to know the overall current through the circuit, because we have a certain amount of current that leaves the battery and a certain amount of current that rejoins the battery, right? And it has the option of splitting down each of these three branches. Well, each of those three branches, therefore, are in parallel. And so we have this, this, and these three are in parallel. And so, well, in order to find the overall current, we're going to have to use Ohm's law, which is V equals IR. However, we need a total R and a total V to find out I. And the R is, well, a combination of two separate things. The R is, in fact, the parallel portion as well as the series portion of this circuit. So what I need to do is I need to figure out what is the equivalence of these three resistors that I've highlighted in pink. So I need to say 1 over the total resistance should equal 1/5 plus 1/10 plus 1/5, which are my three resistors. I'd find a common denominator, and I'd say 1 over RT equals 2/10 plus 1/10 plus 2/10, which comes out to 5/10. And I get 1 over RT equals 5/10. And to solve for the answer, we have to take the reciprocal of this. So the equivalent resistance of the three of those is 2 ohms. Now we have to add to that the 5 ohms that are in series with it. So we have a total of 7 ohms. And then we divide that into 21 volts, and that gets me 3 amps. Now the 21 volts is the voltage from the battery. The 7 ohms is a question of coming up with the equivalent resistance of the three resistors that are in parallel and adding them to the series, which is the 5. Now this 3 amps, that's not the current in the 10 ohm resistor. That 3 amps is the current that leaves the battery and the current that rejoins the battery. But this current has the option of, well, three different paths. It can go down this branch, it can go down the 10 branch, or the other 5 branch. Well, what's the relationship between 5 and 10 ohms? This is a tricky part. The 10 ohms offers more resistance and therefore gets less flow. And what's the relationship between 5 and 10? Well, it's a 1 to 2 relationship. And so the total current is 3 amps. And so we could say I total should be the sum of these three resistors, which is 5, which we'll call I1, plus I2, plus I3. And so the total is the sum of the three, right? So, all right, let's see what we can do with this. We would end up saying I total is 3. And what's the relationship between the 5, the 10, and the 5? The 5s should get 2 times the amount of current that the 10 does. So I'm going to call the 5 a 2x. The 10 is going to be an x, and the other 5 is going to be a 2x. And so when you do this out and we consolidate and find out x, we end up with 3 equals 5x, or x equals 0.6 amps. And there is our final answer to part A. Whereas we're trying to find the current in just one branch, and this 10 ohm resistor offers twice the resistance, and so it gets half the current. So these two 5s are actually getting what? 1.2 amps apiece, twice the 0.6. Now when we're looking for thermal energy, what we're going to do, I'm just going to get rid of this. When we look for thermal energy, we're looking for joules, because thermal energy is the same as any type of energy, which is always measured in joules. But now, well, how can we end up with that? Well, if we know watts, a watt equals a joule per second. Well, we know time period. So if we could find out watts and multiply watts times time, we'll be left with joules. And so, well, we can find out power by saying P equals IV. And now we know I, and we have to use the total I, which is 3 amps, times the 21 volts. And 3 times 21 gets me 63 watts. Well, remember that 63 watts is really joules per second. And I'm being somewhat redundant by writing them both in, but that allows us to recognize that let's multiply by seconds, and that will cancel them out, and we'll be left with joules. And so what we have 2 minutes is 120 seconds. So if we multiply the 63 watts by 120 seconds, we'll get 7560. And really, we think about sig figs, I guess technically we only have one sig fig, right? And so really, if it's 7560 joules, we want to make that significant digits, we have to call that 8,000 joules.